Welcome students to session number 44 of chapter number 5, laws of motion. Today we are going to study an important topic, that is Newton's third law of motion. But before that I need to solve two questions based on the previous videos. Clear? They are very simple. The first example we are going to solve, that is the equation of the motion, the equation of displacement of a motion. Clear? The equation of displacement of a motion is already given to us, that is y is equal to ut plus half gt square. What is equation ut plus half gt square? This is the equation with us. Find force acting on the body. Find force acting on the body. We need to calculate force acting on the body. That's very simple, very simple. The question, we do have displacement y with us. Y is equal to, we are having equation y is equal to ut plus half gt square. Is this clear? Now first step, what we are going to do, we are going to differentiate this, that is dy by dt. That is d by dt of, I am going to do ut plus half gt square. Till this clear? Next step, I am going to separate. So separate means d by dt of ut plus d by dt of 1/2 gt square. Till this clear? U is out, so this is dt by dt. Yes or no? This is dt by dt. Very good. Plus 1/2 g is constant, so d by dt of what? T square. We already studied recently. I have already told you how many few times that d by dx of x raised to n, then this power n, you have to reduce one power for x. So I can use it over here. This dt is 1 plus 1/2 g. This is 2t. I'll reduce one power, 2 minus 1. So my equation is u plus half g into bracket 2t. This 2 cancel. So my answer is u plus gt, that is dy by dt. Clear till this? Perfectly. Now remember one thing, this dy by dt is nothing but what? Rate of change of displacement with respect to time. So I can write over here dy by dt, that is nothing but what? Rate of change of displacement with respect to time. Yes or no? A rate of change of displacement upon time with respect to time, displacement upon time, we do have one value, that is what? Velocity. So I can write this is v. Yes or no? So v is equal to what? Dy by. Instead of this dy by dt, if I substitute v, what I am going to get? V is equal to u plus gt. This is the equation. Perfectly clear? V is equal to u plus gt. Moving ahead, I do have equation of velocity with me. What is the equation? V is equal to u plus gt. So what I am going to do? V is equal to u plus gt. Again I am differentiating dv by dt, that is equal to d by dt of u plus gt. Is this clear? Now next step, we have to separate it. Very good. So separate is d by dt of u plus d by dt of gt. Till this clear? This is constant, so will be what? 0. G is constant, so out dt by dt. This dt is nothing but 1. This is v, g, and I got dv by dt, that is equal to g with the answer. What is dv by dt? Rate of change of velocity with respect to time. Velocity upon time is nothing but what? Acceleration. Very good. So I am going to get here over, there is acceleration is equal to g, because why? dv by dt, rate of change of velocity, rate of change of velocity is acceleration. Is acceleration. Till this clear? So instead of this I can write what? I can write a. Yes or no? I can write a. So a is equal to g. I got equation. Now I want to calculate what? Force. So force, that is equal to what? Mass into acceleration. Yes or no? And the body mass they have given in the question, that is m, and acceleration, that is a. Instead of a I what write? G. So my answer for F is equal to what? Mg. F is equal to mg is my final answer. Here one thing you will be able to notice clearly, that force you got, that is F is equal to mg. Mg is nothing but what? Weight. Yes or no? NF is equal to mg can be happen only case if the body is moving with uniform acceleration under the gravitational force. Under the gravitational force, then only this A can be replaced by G. Have you seen free fall, no? In free fall, what? The body was moving with uniform acceleration under the gravity. Yes or no? Then you can substitute acceleration A, that is equal to G. Yes or no? Similarly, I have substituted A to G. Means this mg represents what? Mg represents the body moving with uniform acceleration under the gravitational force. That's why my force is F is equal to mg. Hope perfectly clear. Very good. Moving to the next example we do have for today. The next example we do have, that is a batsman hits the ball. The batsman hits the ball without changing its initial speed of 12 meters per second. I'm going to tell you that we can consider that this is to be the bat. Clear? And a ball is being hit into direction this. Clear? Back. It is coming with initial velocity and final. Final velocity, if I consider 12 meters per second, then initial velocity will be what? Here the cleared mention in the question that without changing the initial speed, means the speed with which the bowler throws the ball is equal to the speed at which the batsman after hitting the ball from with the bat. The speed are same, initial and final velocity are same, they are same. So I have to write it compulsory 12 only over here because it is given in the question without changing the speed. Clear? So both are 12, but there is one difference of the direction. Can you see? This is from bowler towards batsman and this is from batsman towards bowler. Yes or no? So this is, if this is from bowler towards batsman and this is from batsman towards bowler, then there needs to be minus somewhere. If I am taking this plus, I have to take what? This minus. This negative represents what? Opposite direction. Negative represents opposite direction. This is nothing but action reaction pair. This is nothing but what? Action reaction pair. Hope it is clear. They are asking calculate. They are asking calculate impulse imparted. They are asking to calculate impulse imparted to the ball. To the ball. Now it's very simple. If somebody asks you impulse imparted is nothing but what? Change in momentum. Very good. So I can write over here that is impulse imparted. Impulse imparted, that is nothing but, I know that is change in momentum. That is change in momentum. Is this clear? Also we know that P is equal to what? mv. P is equal to mv. But change means what? Delta P. Mass is not going to change, so it's m. What is going to change? Velocity v. So I can write out the change in momentum, that is delta p, and this delta is nothing but m v m. What is delta v then? Delta is nothing but change in velocity. This is nothing but what? Change in velocity. So change in velocity is nothing but what? Final value minus initial value. So my final is v, initial is v naught. So mass is 0.15 kg they have given. In the question that mass of the ball is 0.15 kg, that is given in the question. So final velocity is 12, initial velocity is minus 12. So my answer is 0.15 into 12 plus 12. Clear? That is 0.15 into 24. Yes or no? If you calculate this answer, you are going to get is what? This is kg meter per second. This must impulse will be imparted to what? Ball. Till this clear? And this direction of impulse imparted is from batsman towards bowler. Batsman towards bowler. So I am writing direction of impulse imparted. Direction of impulse imparted is what is from batsman to bowler. Batsman to bowler. Till this clear? Hope it is perfectly clear. 100%. Very good. Moving to the next theory, that is Newton's third law of motion. Here I've calculated that is nothing but 3.6 unit kg meter per second. Hope it is clear perfectly. Any doubt? No doubt. Moving to the third, that is topic today's, that is Newton's third law of motion. Yes, the next topic we are having, that is Newton's third law of motion. Newton's third law of motion. Now, moving to the topic, I want to tell you what is Newton's third law of motion. To every thing in the nature, every action there is equal and opposite reaction. That is Newton's third law of motion. Clear? For every situation, for an action, there is always equal and opposite reaction. That is Newton's third law. So we can state, or we can define it as, to every action, I can write it as, to every action there is equal and opposite reaction. There is equal and opposite reaction. To every action there is equal and opposite reaction. State Newton's third law of motion. I can give you one practical example of it. That is very simple. Have you seen a man swimming in the swimming pool? What happened? It pushes the water backward. It pushes the water backward. You're able to observe that it is moving in forward direction. The reason behind that is the action caused over here, that is being pushed water backwards. The water is creating a force, it's upthrusting, is moving the body forward. That is due to the force exerted by the water on the body. Clear? First, the swimmer used to push water backward, means force is exerted by swimmer on water. Then same reaction is given by that is water gives a force towards body, which makes the body to move forward. Till this clear, this is a practical example for every action. To every action there is equal and opposite reaction. That is of Newton's third law. Hope it is clear. Now we can consider, suppose we can consider there are two bodies. This is body A and this is body B. I can write there are two forces that is acting on it. This can be considered to be force on body A due to A, force on body B due to A, and this is force on body A due to B. Clear? You will able to notice that this FAB and FBA both are equal in magnitude but opposite in direction. Direction is opposite over here. So I can write over here, there is one thing concluded over here, that is force always exists in nature between a pair of bodies. Force always exists in nature between pair of bodies. So I can write over here one important conclusion. Force always exists in nature between pair of bodies. In nature between pair of bodies. Till this kind of one important conclusion. Here with Newton's third law, you can say that the force exerted on body A by body B, force exerted on body A by body B, yes or no, is equal and opposite, to force exerted by body B on A. Force exerted by body B on A. Clear? So from here I can conclude that the magnitude of force acting on body A by B, that is equal to force acting on body B by A. Magnitude is same. Means action is equal to reaction. So you can say force of action that is equal to force of reaction. Clear? But remember one thing over here, direction is different. So if I want to write FAB, this is equal to minus FBA. Clear? Direction both are equal, but minus represents opposite direction. Till this clear perfectly? 100% clear. Magnitude is same, direction is opposite. That is a Newton's third law of motion. One thing concluded from here. What is concluded? There is no isolation of force. Yes or no? There is no isolated force, means force never exists, or force always exists in pair. Clear? Your conclusion over here is force always exists in pair. Single force cannot exist. So here always force exists in pair. So I can write over here that is force exerted on A by B, that is equal to minus force on B by A. Clear? Force always exerts in pair. exist in pair. Clear? Single force never exists. Single force never exists. This is my conclusions. Clear? Remember one thing, out of these two forces, one can be considered to be action, second can be considered to be reaction. So there is no relationship between cause and effect of action and reaction. There is no relationship between there is no relationship of cause and effect between action and reaction, between action and reaction. Hope it is clear perfectly. We'll see more topics into the next session. Till then, thank you. Before converting this video, I want to give some conclusion for Newton's third law of motion. So I can write over here, conclusions of Newton's third law of motion. Third law of motion. The very first conclusion over here is Newton's third law of motion can be applicable to irrespective of the nature of the force. There is no concern with the nature of the force, whether nature is gravitational force, mechanical force, electrical force, or any other force. Newton's third law of motion can be applicable. So you can write first point as Newton's third law. The application of Newton's third law of motion is irrespective of nature of forces. Clear? It is irrespective of nature of forces. Second point, remember, action and reaction always acts on different bodies. If they act on the same body, then the resultant force is zero and they will never be uniformly accelerated. Or they are not going to perform uniform acceleration motion. Clear? If the resultant force is zero, how acceleration will come? Yes or no? So you can write that action and reaction always acts on different bodies. Till this clear? Third point over here is action and reaction can never balance each other. Means action and reaction can never cancel out each other. Though they are opposite in direction, though they are equal in magnitude, why they don't cancel, sir? Why they don't cancel? The reason behind that is, though they are equal in magnitude, opposite in direction, but they don't cancel each other. The reason behind that is they are acting on different bodies. They are acting on different bodies. They are not acting on same body. They are acting on different bodies. Hence, different bodies cannot balance them. Hence, you can say that. What you can say that action and reaction can never cancel out each other. Can never cancel each other. You can say more precisely. Clear? The last conclusion I can come to you, that is the application of Newton's law of motion is irrespective of nature of forces. Action and reaction are always act on different bodies. Like action and reaction can never cancel out each other. The last point I wish to say you about the conclusion for Newton's third law of motion. Can anybody guess what is the last point with us? Can anybody guess? What is the fourth point of this last conclusion? Last conclusion is that no action can occur in absence of reaction. No action can occur in absence of a reaction. So what does this mean? I can give you one simple example in order to clear the concept of this. Have you seen Tug-of-War? There are two teams pulling the ropes, yes or no? What happens if there is other end is free, only one team is pulling? Is it possible to apply force on the rope if other end is free? No. What happens when both the teams starts pulling? Means one is action, the other is reaction. Clear? So if only one team is pulling and there is no need to pull only, there is no you are not able to exert force from one team if the other end is free. Yes or no? So in the case of tug-of-war, one is action, another is reaction. If one team is pulling, there is action, other team is pulling, that is reaction. Till this clear? Hope we'll see further more topics into the next video. Thank you.